Hello everyone. In this video, I want to provide a gentle introduction to using closures in Swift. There's a lot of reasons you'd want to learn about using closures, including the fact that they are everywhere in iOS. So if your goal is to do iOS app development with Swift, then you'll probably want to learn about closures sooner than later. So let's start off by talking about functions, because really a closure is a more general version of a function. Or said another way, a function is a more specific version of a closure. Specifically, a function has a name, but a closure doesn't have a name. All right, so I'm going to have a section here where I'm going to take some notes on functions. So first off, a function is a first-class citizen in Swift. So what do I mean by that? I mean that you can use a function anywhere you can use a value in Swift. So what do I mean by a value? Like, for example, 3. 3 is a value. The string hello, right? Double quote, Hello, double quote, that's a value. Maybe a book object that represents the first Harry Potter book, that's a value, right? If you define some custom struct, perhaps called book, then when you make a book object, then you've got a value of that book type, okay? So all of these values I just gave you examples of, they have types, right? 3 is an int. Hello is a string, right? Harry Potter book 1 is a book. So let's take notes about what does it mean to have a value. Okay, every function has a type, and the type is based on the function signature. Let's see an example first. So let's say I have the function type, open paren, close paren, arrow, void. What is this? Well, this is the type of all functions that accept no arguments. Hence, right here, the parameter list is empty. So the type of all functions that accept no arguments and don't return a value. And the don't return a value part is denoted by the arrow, which is denoting the return type, and void, which says this function doesn't return a value at all. Okay, so the type is based on the function signature. So if you have a function, perhaps something as simple as print 3. Okay, this is a very simple function. It'll just always print 3. You can inspect the signature to determine what is the function's type. Okay, so I'm looking at the function signature here. This function print3 doesn't accept any arguments, so it has no parameters, and it has no return value because it doesn't have an arrow here. I could also put arrow void. This would work as well. So that's why its type is empty parameter list return void. Okay, so this type represents this function, but it also represents all functions that don't accept any parameters and don't return a value. So let me just show you a few more types of functions, and I'm just going to make these up. They'll be somewhat random. Maybe I have a function that doesn't accept any arguments, so it has no parameters, but it returns an int. So maybe it rolls a 6-sided die and returns the result of that roll. Let's say I have a function that accepts a double and returns a double. Maybe this is the square root function and accepts a double and then returns the square root of that double as a double. Maybe I have a function that accepts an array of strings and an int, and perhaps it returns a double. Let's say, as another example, getting a little crazy with this one, maybe I have a function that accepts an int, a double, and a float, and maybe it returns more than one value. Perhaps it returns something called a tuple, which is a nice way to package up multiple values and return multiple values. Yes, you can do that in Swift. Okay, so here the return value is the tuple, the 2-item tuple that contains a double as the first item and an int as the second item. So really there's no bound on all the different types of functions, right? Because you could put 10 doubles in as your parameter list and maybe return 100 doubles, right? So you really need to inspect the function signature in order to determine what is the type of this function. All right, now that we've talked a little bit about function type, let's talk about a local function. So a local function is a function that is defined inside the body of another function. You may never have defined a function inside the body of another function before, but we're going to do it today. Closures are typically functions that are defined inside the body of another function. And you might be wondering, well, why would you do this? Okay, I'm going to provide several reasons, but let me perhaps equate this to something you might be familiar with. If you've ever defined a type inside the definition of another type, then you're working with a nested type, right? Like perhaps, for example, you've defined maybe a point struct or a point class inside of a circle struct or a circle class, because circle is the only type that's ever going to use a point. It's going to use it to represent its center on like an XY plane. Then you might define that point type inside of circle because circle is the only one that needs it, right? If you've worked with these types of kind of local classes or local structs before, the notion is the same with a local function. You may also have worked with perhaps string indexing before, where in order to index into a string in Swift, you needed a string.index object, right? A string.index object. Well, index is a nested struct that's defined inside the definition for the string struct. Okay, so you might have seen this idea of nesting types before. Hopefully that can help you when you think about what does it mean to nest a function inside of a function. Okay, so let's take some notes on reasons why you might do this. And now this is specific to working with a local function. All right, you might do this because you're defining a helper function that is only used in this function. Another reason, perhaps you would do this in order to keep the code that is highly cohesive near each other for readability. So an example would be maybe string.index, right? If you're looking for the definition for the index struct and you're already looking at the string struct, then you don't have to go very far in order to find that definition, right? It's more readable. Define it where you use it. You might also define a local function because that local function is only going to be called one time, or perhaps it's only going to be called in one spot in your code. I don't want to say it's only going to be called one time because you might have it in a loop and it'll be called multiple times, but you're only using that call to that function in one spot. And then one more reason, perhaps you're using a local function because this function is going to be passed into another function as an argument. All right, now we've had some background reviewing functions. What does it mean for a function to have a type, and what is a local function? And now I'm ready to introduce to you what is a closure. So we've got our new section here on closures. A function that has no name is called an anonymous function, okay, aka closure. So let me give you a more formal definition, okay? A function that has a name is called an anonymous function. That closure could be a local function if it's defined inside of another function. A closure, said in another way, is a piece of functionality that you can pass around in your code to be executed at a later time. I do want to make one note here, which is about how closures can capture their external references. It's just something good to keep in mind. In this gentle introduction, we're not going to see a good example of this, but once you get to iOS, and if you watch some of my other videos, you will see an example of this. So closures, they capture, and I'm putting capture in quotes because this might be a new term for you, capture their external references. Okay, so that means when you define a closure, right, it's a piece of functionality, that closure doesn't execute until it's called at a later time. Okay, so if when you define the functionality of your closure, you are referring to perhaps some properties, some references that are in variables, right? You're using what's in scope inside of this closure definition, but when the closure executes later, perhaps those references go out of scope, you would be in trouble, right? But closures are going to capture those references and keep them in scope. They're going to keep them in memory so that when the closure does execute, you're not going to get some, seg fault or some, kind of null pointer exception saying, oh, this has been deallocated, you can't refer to it. Closures will keep those external references in memory, even if the function they're defined in has returned. Okay, that's just a little note, something to be aware of. Let's start with the absolute basics of working with closures. So time for an example. All right, I'm going to have this really simple function called say hello. It's very much like our print 3. And all it's going to do is it's going to always just print out hello. Okay, so you can see that the type of say hello is no parameters, no return value. Okay, so this is the type of say hello. So now let's define another function. And this function is going to be a function that can execute any functions of this type. All right, so I'm going to call this execute void function, kind of a long name, but very verbose and very clear about what it does. So this function executes void functions. So it's going to accept an argument, and we'll have a parameter called f to store that argument. The type of that incoming argument and how I'm going to define my parameter is a function that accepts no parameters and returns nothing. So now I can execute f. That's it. When I call execute void function and I pass in a function that doesn't accept any parameters and doesn't return a value, I can execute that function as such. So let's see an example. I'm going to call execute void function f, and I'm going to pass in say hello, right? Because say hello is a function that has this type. So execute void function can accept this function as an argument. It'll store it in the parameter f and execute f, which will just be an alias for say hello. So as I'm typing execute void function, note that Xcode knows that I am working with a closure, okay, right? What I'm going to pass in is going to be a closure, either a name closure, a function, or I'm going to define a closure right here when I need it. I'm not going to let Xcode auto-complete this right now. Okay, soon I will, and I'll show you what Xcode does for you. It's very helpful, but I'm going to be very verbose, and I'm going to write this whole thing out. All right, so I'm going to call execute void function. I'm going to pass in f, say hello. All right, so let's run this, and we should see hello. And we do. So execute void function is going to be called. I'm going to pass in a function for it to execute. Okay, that will be stored in the parameter f, and then I'm going to use f to call say hello. Okay, so this is parameterized, right? So I can pass in any function that accepts no parameters and doesn't return a value, right? Any function with this type I can pass in to execute void function. So this time I'm going to call execute void function, but instead of passing in a function that I've already defined, meaning I've given it a name up here, I'm going to instead pass in a closure. Okay, so this closure is going to be a function that doesn't have a name. It's an anonymous function. All right, here we go. So once again, I'm going to type this out very verbosely. Execute void function. I'm not going to let Xcode finish this for me. I'm going to type it out. All right, so I'm going to have my function f, okay? I'm going to put my argument here, but this time I'm going to define a closure to represent the piece of functionality I want execute function to execute. Okay, So here's what I'm gonna do. I'm gonna have curly bracket, curly bracket. Okay, this is my piece of functionality. This is the start of my closure. I'll take some notes in here. So closures start with open curly bracket and end with closed curly bracket. On the first line, we specify our parameter list, our return type, and the word in. Okay, so in is a keyword in Swift to separate the header of our closure from the body of the closure. So right now I'm in the body of the closure. So let's just say that this function, okay, this anonymous function, we're writing closure, is simply going to print out goodbye. That's all it's going to do. This is the body. Okay, so now I need to come up to the start of my closure and define the closure's header. Okay, so we're going to specify our parameter list. So what is our parameter list here? Well, it is empty. It's not going to accept any arguments. What is its return type? Void. It's not going to return any values. And then the end of my header, I'm going to put in to separate my parameter list, my return type, from the body of the closure. And now when I run this, we're going to see goodbye, right? So execute void function, this is a call to the execute void function in which I'm passing in this closure as my value for f. We're going to execute that closure on line 48, and that's why we're getting goodbye. Okay, so right here, this is a function, but it doesn't have a name, right? So recall up here, I wrote a function that has no name is called an anonymous function, aka a closure. Okay, a little bit of a preview here. So Swift has a lot of syntactic sugar, which is also known as shorthand, but syntactic sugar sounds kind of fancy and kind of fun. And the syntactic sugar or the shorthand used with closures is a way to make your closure code shorter. So let me show you an example of this, and then later in this video, I'll provide a very detailed breakdown of what is going on with the syntactic sugar. All right, so let's say I want to call execute void function. This time, I'm going to let Xcode type this out for me. Okay, so if I press enter and I see my type here and press enter again, I'm going to get this really shorthand version of execute void function. Like it doesn't even have an open paren, close paren. Let me do this again, and I'm going to choose the other option from Xcode, which is the second one. Okay, no open paren, no close paren. It'll look exactly the same. Okay, so two shorthand ways to write a closure. And I will explain later what are the rules for reducing this long thing down to this really short thing here. That's it. Execute void function is going to execute this closure, and we're going to see good day. Okay, that was just a little preview. We'll see more here shortly. All right, time for another example. So we just did execute void function, which can accept any function that has no parameters and no return value. So now let's do a slightly more complicated example. This is going to be a function that accepts and calls a function of type int parameter return int. All right, so I'm going to call this function, let's say transform random integer. Okay, it's kind of a goofy function, but this is what it's going to do. It's going to accept an integer, which is going to be a random integer, and that function is going to return some transformation of that random integer. So in order to call f, I'm going to need a random integer to pass it. So let's do random is assigned int dot random, and let's do a random number in say 1 to 10 inclusive of both the start and the endpoint. Now I'm going to let transform num be assigned f, passing in random. Okay, so random is going to be my int argument that'll be stored in an int parameter of f. Okay, f is going to do some sort of transformation to that random number and return an integer. And you'll see I'm storing that return value from f in transform num. And just so we can see what's going on, let's just print out random and transform num. Now that we've defined transform random integer, let's call it. So we're going to call transform random integer, passing in a closure that doubles a number. All right, so I'm going to write transform random integer. I'm not going to let Xcode code complete this for me because it's going to apply some syntactic sugar. Like you see, the open paren, close paren is gone here. I'm going to be very verbose, and we're going to write this out using longhand closure syntax. And then I am going to come back and explain what are the rules for shortening your closure code. Okay, so that means we need our open curly brace and our closed curly brace. We need to have a name for our incoming integer parameter. I'll call it value. We've got our return type, which is int, and then in to denote that we are now going to begin the body of our closure. Our body is simply going to do value times 2 because we're going to double the number. All right, I'm going to run this and we'll see output from line 71. So random is 9. When 9 is passed to our closure, which f is storing as a value, then 9 is going to be doubled and we'll see 18. Awesome. All right, I want you to try this out now. So your task is going to be to once again call transform random integer. And this time you're going to pass in a closure that squares a number. That squares a number. So go ahead and pause the video and try it out. If you're a little stuck on the syntax, because it is a lot to learn, take a look at our example with doubling a number. All right, hopefully that went well for you. Let's go through it. Transform random integer. Have my curly brackets here. Same thing, I need to have a name for my parameter. I don't have to use value, I just made that up. So maybe I'll do my int param, something like this, returning an int. And then in my body here, I'm simply going to return my int param times my int param. All right, so the random number for this second call to transform random integer is 5. We're passing 5 in when we call f, which is going to execute this closure here. And we'll see that 5 times 5 is 25. The return value is 25. That's stored in transform num. And we see from line 71, 5 space 25. All right, awesome. It's working. Now, as promised, I said I would come back and talk more about the closure shorthand or the closure syntactic sugar. Let's do that now. So what we're going to do is go through a few rules that can be used to shorten closure syntax. And for each rule, we will shorten our closure syntax here until we get to the shortest possible form, which is somewhat similar to what Xcode will code complete for you when you kind of press enter as you start typing a call to a function that accepts a closure. All right, so the first one. If the closure has only one line, which is the case for our closure here, its body has only one line, you can omit the return word. Swift will return whatever that one line evaluates to. Okay, so that means that I've got one line here. I can delete this return statement and my code will still compile and run. Awesome, it's still working. Next rule, Swift can infer the return type. Okay, so whatever value you're returning, Swift can infer its type, which means I don't have to specify it here. So let me see if my code still builds and runs. It does. Awesome, our code's getting much shorter already. Next, we can omit the parameter list and use general placeholders instead. Okay, so what do I mean by a general placeholder? Well, if I omit the parameter list, then I'm going to be losing the name, the identifier, my int param. It's gone. Now my parameters are effectively anonymous, but they still have an order to them, the same order at which they're passed in. The arguments are passed in for them. So like $0, this can be used to refer to the first parameter. Okay, so like zero-based indexing to denote the position of the parameter. $1 can be used for the second parameter, $2 for the third parameter, so on and so forth. So we only had one parameter, okay, so that would be at the 0th position. So instead of saying my int param, because I've deleted where I declare that identifier, I can put in $0, and my code will still run. Let's get another number, something other than 1. There we go, 8 and 64, awesome. It is still working. Now we need to talk about trailing closures. So a trailing closure is a closure, as the name implies, that is the last argument to a function call. A trailing closure can be outside of the parameter list on your function call. And if the closure is the only argument, then you don't even need the open paren, close paren at all. So this means that I can define my closure outside of the parameter list like this. I will need to delete this extra paren down here, but this will compile and run. Now, since my trailing closure is the only argument in my function call, I don't actually need the open paren, close paren at all. So I'm just going to delete them and my code is going to run just fine. All right, now we're almost done. We can shorten this even further just by getting rid of our new lines here. And now we have a one-liner for transform random integer. Now let me show you how Xcode will code complete for you and how, depending on the closure that's being passed in your function call, you might get two different code completes to show up. So like for example, if I do transform random integer, press enter, okay, I'm gonna get some syntax here for my closure, but note that I don't have the open paren, close paren here at all. Let's say I wanna call my execute void function. I've got two different code complete options for execute void function. If I go with the second one, we're gonna see that I don't have an open paren, close paren at all, and I don't actually even have our parameter list arrow return type, right? The function type of the closure, I've just got this really short call to execute void function definition for my closure. All right, so that wraps up our shorthand. And let me just close the video by saying that closures are everywhere. You'll start to see them pop up here and there. So for example, if you want to keep practicing with closures, but maybe you're not quite ready to head over to iOS just yet, map, reduce, and filter. These are common operations on arrays. They are often written using closures. So I'd recommend playing around with those. Here are some examples in iOS of where you might see closures. These are nice, kind of easy introductions to closures. I would take a look at alert controllers because alert controllers use closures to execute code later. Okay, so what is an alert controller? An alert controller is used to show an alert dialog. So if you ever get prompted with kind of a little gray box with a few options like approve or decline, something like this, closures are used to execute code based on the user's choice. If they press like approve, for example, then the closure that was given to the alert controller for the approve button action will execute. Another example is timers. So timers use closures to execute code periodically. Maybe you want to set a timer that runs every second and you want to pass that timer a closure so that that code in the closure executes every second. That's another great example of closures. And I'll just end here by saying lots more. They aren't going away, meaning moving forward with your Swift knowledge and perhaps your iOS app development experience, you're going to see a lot more closures. They are very useful and they are used quite often in various frameworks. And you'll find that you'll want to use them as well. Right now, they might seem a little overwhelming because there's so many rules and so many things to keep track of. But you will find that you'll start to like to use them. Also, once you get to the iOS frameworks, I did talk a little bit about how closures capture their external references. I encourage you to return to this notion and spend some time understanding what does it mean for a closure to capture external references, because I kind of just glossed over it here, but we will see some examples of it when we return to iOS app development. All right, that is it. Thank you so much for watching.